Good morning. Am I audible?
Yes.
Okay. Dear participants, a gentle reminder, please make sure to mute the microphone and switch off the camera during the presentation. You can raise your questions in the chat box or in the live chat within YouTube during the discussion part. Chemistry 2K20, a 5-day international webinar series organized by the Department of Chemistry, aims to provide a forum for faculty members and researchers from various areas of chemistry by providing a platform and share latest cutting-edge research findings and results about novel aspects in chemistry. Chemistry 2K20 was inaugurated on 25th November 2020 by Honorable Vice Chancellor of MG University, Dr. Sabu K. Thomas, with a keynote address, Advanced Sustainable Polymeric Materials. And today in the second session, we have another eminent scientist, Dr. Vijay Mohanan K. Pillai, for delivering the lecture. For those who are joining, I repeat, a gentle reminder, please make sure to mute the microphone and switch off the camera during the presentation. You can raise your questions in the chat box or in the live chat within YouTube during the discussion part. Thank you.
Hello, good morning.
Good morning, sir.
Good morning, sir.
So, can you see me?
Yes.
Yeah, somehow I thought that it's 11 o'clock. It was there in my mind. That's why I'm sorry.
Oh, it's okay, sir.
Okay. So, I am audible clearly?
Oh, yes.
Okay.
Once again,
So
very good morning, all of you. Sorry, sir.
No, I'll just check whether you can see my slides. Then you can go ahead.
Okay, sir.
Just 1 second. Is it visible? Is it visible now?
Yes.
Okay. I think, yeah, please go ahead.
Once again, very good morning to all of you. We welcome all of you to the second session of Chemistry 2K20, the 5-day international webinar series organized by Department of Chemistry and IQAC of Marthoma College, Chungatara, in collaboration with Kerala Higher Education Council. Now, before I introduce our respected speaker, let me invite our dear principal, Professor Reina Thomas, to speak a few words. Teacher, can you hear me?
Okay. Yes. Thank you,
Teacher?
Anupama.
Yes, miss.
Can I start?
Yes, miss. Yes, miss. Please.
Okay. Good morning, everyone. Chief guest of the day, respected Dr. Vijay Mohanan Pillai, sir. College Bursar, Reverend Mathai Joseph. IQAC Coordinator, Dr. Rajiv Thomas. Dear participants, faculty and staff members, and dear students, it is indeed a happy and proud moment for the Department of Chemistry and Marthoma College that the Chemistry Department could organize this 5-day international webinar series, Chemistry 2K20, in association with the Kerala State Higher Education Council. In the inaugural session, we had a wonderful presentation by the Vice Chancellor of Mahatma Gandhi University, Professor Sabu Thomas, on the advances in the field of nanomaterials. The revolutionary advancements and developments in the engineering of sustainable molecules. Today, we have yet another scholar and academician who is also working with the sustainable energy sources for the future, Even in the midst of his busy schedules, Vijay Mohan sir has given his quality time to us. On behalf of the Mahatma College community and the participants of this webinar, let me welcome you, sir, once again with all our heart. Let's have an enriching session with sir. The efforts of the Department of Chemistry and IQAC is greatly appreciated, and I congratulate all the faculty members of the department also. Dear participants, have a great learning experience and interact well with sir. All the best. Thank you.
Thank you, teacher. Doing chemistry in the time of pandemic, an opposite topic of discussion. With great privilege and pleasure, I welcome Dr. Vijay Mohanan K. Pillai to Chemistry 2020. A few words about our esteemed speaker. Dr. Vijay Mohanan K. Pillai is currently Professor and Chair of Chemistry, Indian Institute of Science, Education and Research, Tirupati. He is an ex-director of Central Electrochemical Research Institute, Karaikudi. And his major research interests include electrochemistry, electrochemical devices, nanostructured materials, energy storage. He has 269 publications and many honors and awards in his credit. Scientist of the Year Award by NCL Research Foundation, Chemical Research Society of India Bronze Medal, MRSI ICSC Superconductivity and Material Science Annual Prize by Material Research Society of India, National Prize for Research on Energy, Materials and Devices by JNCASR, Chemical Research Society of India Silver Medal are a few among them. With immense
Hello?
Anupama?
Yes, sorry, I had an interruption.
Okay. Please
Doing
go ahead.
chemistry. Okay, sir. Doing chemistry in the time of pandemic, an opposite topic of discussion. With great privilege and pleasure, I welcome Dr. Vijay Mohanan K. Pillai to Chemistry 2K20. A few words about our esteemed speaker. Dr. Vijay Mohanan K. Pillai is currently Professor and Chair of Chemistry, Indian Institute of Science, Education and Research, Tirupati. He is an ex-director of Central Electrochemical Research Institute, Karaikudi. Some of his research interests include his major research interests include electrochemistry, electrochemical devices, nanostructured materials, energy storage. He has 269 publications and many honors and awards in his credit. Scientist of the Year Award by NCL Research Foundation, Chemical Research Society of India Bronze Medal, MRSI ICSC Superconductivity and Material Science Annual Prize by Material Research Foundation of Society of India, National Prize for Research on Energy, Materials and Devices by JNCASR, Chemical Research Society of India Silver Medal are a few among them. With immense pleasure, I once again welcome you, sir, to deliver the lecture.
Thank you. At the outset, let me thank Principal Professor Reina Thomas and Dr. George, who has been interacting with me for this kind invitation. I'm sure that all the faculty members who are listening to me and also the students, they all know that the pandemic triggered a rapid switch to our online classes. So it created a lot of stress to students as well as teachers because we have to adjust to the new way of life. In fact, this slide itself, you can see all of us, the brain is preoccupied by corona. When you touch something, will you get corona? When you talk to another one, if you have, in case you forget this mask, will there be a problem? So many of us who have been playing continuously, either football or basketball or volleyball or any type of game. We can't do any. Most importantly, we can go to laboratory. Laboratory is actually the lifeline of chemistry. Chemistry is a great enabling science, but we like to do chemistry. We like the smell, whether it is benzene or acetone or acid, or we always get addicted by the smell of chemicals, the color of chemicals. So that is what is great about chemistry. Chemistry has come to this stage using all these senses: sound of crackling, sound of gases, gas bubbles coming out. So anyone who loves chemistry, if you look at the great chemists, they have all started liking chemistry from the childhood. Even some of them became doctors and physicists later, but they love chemistry. Richard P. Feynman is one example. There are many great people. Although they became physicists, their primary love affair was with chemistry. In fact, Oliver Sacks, great neurologist. But as a child, his most interesting, most impressive time he spent doing chemistry, taking some beaker, taking some test tubes, doing that. He has written a book called Uncle Tungsten, many books. So there are people, the reason I elaborate this is that it was like chemistry because of the laboratory work, not because you want to read all the books, not because you want to do, but you like, what is it? Suppose you smell a fish, rotten or not, you get the smell of an amine. You know that this fish is rotten because if you are a chemist, you immediately, your brain triggers a chemical. Ethylamine is there. Methylamine is there. Similarly, some fruits you smell, you immediately get, oh, acetaldehyde. So this is what makes a chemist different from another individual. So the pandemic has created havoc in our life, because once a chemist can't go to the laboratory, then you don't have, you don't like chemistry at all. This is why the life has changed dramatically because of COVID. COVID, of course, is not a new phenomenon. Instead of COVID, there have been several pandemics in the world. At some stage, there was a plague in London, somewhere around 1665, where 10%, 15% of the whole population died. So pandemic was there in the world. Sometimes much more serious pandemic happened. What is new about it is this type of an effect, because we are all in one global village. One place, one incident happens, it affects everywhere. That is why there is something special. So we all have to adjust with this new way of life, new online classes, virtual laboratories. So I thought it may be important for me to talk to you two aspects. One, how COVID-19, the onset of COVID-19 and their humanity, how we have thought about, how we have changed the way of our life, especially in chemistry, laboratory aspects, online classes are there. This is how the general, almost all education system got changed. So I thought today I would talk about that. At the same time, I would also talk how chemistry deals with not only this pandemic. I will also tell how chemistry is prepared to offer solutions to almost all challenges we face. Globally, if you list 10 most important challenges all of us face, of course, COVID is number one. Then we have several other challenges: water, not getting enough drinking water. Another challenge, energy, another challenge. So if each one of you write 10 worst problems faced by humanity, 1, 2, 3, 4, 5, you will be surprised to know that chemistry offers solutions. So that is why I am delighted to be a part of this program. I am glad that my dear friend Professor Sabu Thomas spoke to you about revolutionary advances in nanosciences. Revolutionary advances in nanoscience also has offered a lot of things about COVID. I would tell you about how three-dimensional printing and an outcome clearly from nanoscience technology. How does it help you to make better masks, better respiratory covers, and even sometimes advancement in nanobiotechnology gives you entirely new type of vaccines. How do we manipulate messenger RNA in such a way that once it is there, it triggers a strong immune system not to allow virus to enter, including the COVID-19 virus. So I come from an institute called ISER, Indian Institute for Science Education and Research, ISER Tirupati. Government of India has started a set of new institutions somewhere around 2007 to focus more on science. So just like IITs where we focus more on technology, Government of India wanted to have more importance given to basic science, physics, chemistry, biology, and mathematics. For these institutions, of course, they are centrally funded institutions. 5 such ISERs were started in 2007-8. 5 ISERs included one in Pune, another one in Kolkata, then one in Mohali, then one in Trivandrum, and there was one more ISER in Bhopal. So once they started these 5 ISERs, initially, of course, you need to make a big, huge building, more laboratory infrastructure. Over a period of time, 2 more ISERs were started, one in Tirupati and another one in Berhampur. So you can see now we have around 7 ISERs catering to the needs of the entire country. I belong to ISER Tirupati. 2015, the institute started with and most of these ISERs will have a BSMS program. BSMS is on the basis of either JEE, after 12th standard you write a JEE examination, or there is another route called what is called KVPY. So this is again a separate route. We have the BSMS students join us, and then there is an integrated PhD. That means after the BSc chemistry, you can apply directly for an interview, and then you join for integrated PhD. Then there is a PhD admission. PhD admission is again based on CSR UGC, or sometimes there is a combined JAM test. All the ISERs conduct together a test. And we also have postdoctoral fellows. So roughly in ISER Tirupati, we have around 460 BSMS students, 50 integrated PhD students, 92 PhD students, and 35 postdoctoral students. Total roughly around 625 now. And 46.5% they are girls. We have around 60 faculties and 66 non-teaching faculty. So you can see what is interesting is that this is one of the youngest institute, but adjoining acre, we have IIT coming up. So we are now operating from a transit campus. It is a campus of an engineering college called Sri Rama Engineering College. But the first batch of our BSMS students have graduated last year, and second batch admission is going on. I'm sure the new batch will join, maybe around 150 students will join this year. We call them as the BSMS batch of 20. So what is interesting is that ISER is an institution. It's a new set of institutions where the education is done at a very innovative level by doing a lot of experiments. So when the labs are closed, we have problems to bring innovation. That is the reason why COVID has affected us, all of us. Of course, for ISERs a little more, because for us experiment is a way of life. I'm sure all of you know how COVID has affected globally. Right now, the recent statistics says that almost 1.4 million people died because of COVID. And almost 61 million people have been affected globally. India, of course, India also the number is quite huge. We have around 0.2 million people got infected in our country. Luckily, 8.68 million recovered, but almost 1.3 lakh people died due to COVID. Even in Kerala, I'm sure at least few thousand people died due to this. So we say sometimes that planet Earth is closed for repairs, because it is the entire planet Earth which is affected. Not even one country is spared. So why does it happen? How does it happen? These are larger questions. But what is important is that there have been serious experiments to stop this. 3 sets of vaccines are at least ready. And we also look at some of the positive aspects. Due to COVID, employment was lost to large number of people. Many chemical industries closed. And there were also some positive effects. For example, in many countries, air became very clean, water became clean, CO2 emission dropped dramatically. For example, in China, many factories were closed because of COVID, and you can see a perceptible change in the quality of air and water. Even in India, Ganges water quality improved. Europe, again, the water quality improved. So these are all certain things, positive effects. But education sector, industrial sector, transportation sector, everywhere you will see that COVID has played havoc. Many of these institutions, you can see classrooms are all empty now. Nobody is there, only bench and desk. Many institutions are closed. You only have online classes, you cannot even enter. And many private institutions, teachers lost job. And many places, what happened, your salary depends on how many hours of class you take. And they are not like a government institutes. So once class is not there, you don't get money. Some of the progressive institutions, of course, they continued. They asked the teachers to take online classes, digital. So chemists have learned how to carry out digital classes. Chemistry becoming more and more online resource based. Some places you have a mix of both. You have online classes and you also send recorded videos so that people can do some experiments, at least at home. Do some experiments at home, sometimes data analysis at home. So we call it as hybrid mode of teaching. So many well-known universities in the world resorted to completely online, sometimes recorded, sometimes hybrid teaching. For example, institutes such as MIT or Cornell, some of the world's best institutes in Harvard, they open the laboratory for PhD students after some time. But every week they have a COVID test. What type of COVID test is done? Again, very interesting to see that most of these chemistry plays a critical role. It's a doctor who prescribes the vaccine, but the vaccine is made by chemists. Drug, same way. Doctor prescribes a drug, but who makes the drug? Chemists. So chemists are, and as a result of COVID, there were a lot of changes on society. People became afraid, but people also changed their opinion about chemists. Earlier, chemists means people did not like chemists. Oh, chemistry, oh my God, these are the people who create so much of problem. They make bombs, they make our water polluting, they make dirty materials surrounding, they make this plastic which is lying there everywhere. We don't have a respite to escape from plastic. So chemists are funny fellows. This was the image of chemistry in the society. It is no wonder because from the beginning, if you look at history, scientists were considered as madmen. And chemistry, among scientists, chemistry was considered as the worst. In fact, I am sure some of you may remember that long ago, I'm talking about something like 1300, 1400, chemistry was banned. Even before Galileo and Copernicus came out with their books on science, chemistry was banned because initially the origin of chemistry was linked with alchemy. Alchemy, al is an Arabic word, the alchemy, because that time people believed that chemists are all magicians. They know how to convert all basic material to gold. So we are talking about the prehistoric times. Even before Lavoisier, who is the modern person who made a strong footing of chemistry. I'm talking about even 500 years before Lavoisier. So people have banned chemistry because chemistry had all these, funny images. Now you look at this. Society has changed its opinion about chemistry. Most of the people, in fact, the politicians, they all consider because they are all asking what happened to the vaccine. When are chemists coming in with a new drug? Chloroquine, and all, everybody knows now. Even the lay public know. So one important advantage is that people became more respectful for scientists in general and chemists in particular. Teaching is something important because teachers mold the next generation of citizens. That is why teaching and education is always a noble activity. Many institutions opened online classes, digital libraries, online conferences. In fact, every week I have a talk. In fact, when I was contacted in the beginning, I was only worried about the date because today afternoon we have another talk by Professor Govardhan Mehta, who was a former director of the Institute of Science, one of the world's, one of the India's best known face internationally in chemistry. Professor C.N.R. Rao and Professor Govardhan Mehta. So Govardhan Mehta is giving an online talk in the evening where I have some 5-10 minutes talk. So please remember that every week we have programs, online programs. And one of the important advantages is that it doesn't matter. You can be in Chungatara, you can listen to MIT, you can listen to IIT Delhi. This is again something which is fascinating. It doesn't matter where you are. You have access to some of the best teaching in the world. There are national programs I would also spend few minutes to talking to you that there are virtual laboratories accessible from anywhere. From your college Chungatara, you can do experiment using virtual laboratory. That's why I thought I should talk on this. So students and teachers, whenever you have a doubt, please ask in the chat box, type in the chat box so that I can answer once the lecture is over. So digital chemistry classes were started in many of these institutions but still digital classes we have a problem because we miss the enthusiasm of the students, enthusiasm of the teachers and students that the body language is extremely important. Eye contact is very important. So if you are a good teacher, as many of you are, you know how crucial it is the body language and eye contact. Without that, this gives you continuous feedback. That is missing in online classes. More importantly, there are problems. Online classes, at the beginning, I used to have something like 140 students in a general chemistry class for first year. When I start the class, everybody is there. Once I start the class, after 5 minutes, sometimes video will go blank. They mute it, and you don't know where they are. And when you end the class again, they are back. And sometimes there are genuine problems. One student was missing, and I sent a message, and I called the student. Where are you? He says, sir, in my house, I get connection only in the bathroom. So he has to be only in the bathroom because the range is not there any other. He joins by a smartphone. So there are genuine infrastructural problems, but large number of students and teachers found problems challenging, especially with the large classes. So for large classes, when you do online, we always make sure that if there is 1 hour lecture, we'll have at least 2 or 3 breakout rooms, breakout sessions. So if the students are, let's say it's a large class like 150, make sure that 50, 50, 50, you have a separate tutorial sessions. Otherwise, it will be difficult. You can send recorded files by internet or by email. And then sometimes this recording, you can also do experiments. You can do experiments and the microfluidic paper-based devices students can easily do in the laboratory. Certain areas it is very easy. Some areas it is very difficult. Now, this is one side. So chemists got larger respect because of the pandemic. People were afraid of pandemic. They know that the solutions will come from chemistry and pharmaceutical chemistry, medicinal chemistry, new vaccines. This is one. Second issue is that there are areas where chemists play a critical role in making diagnostic tools. For example, biosensors. Can you quickly detect the virus? Virus can be detected very easily, cost-effective manner, either by a color change or by a voltage change. There are many ways of designing a biosensor. So you may have to take a biomolecule, in some cases some specific proteins or lectins or something which will absorb the spike proteins in coronavirus. Spike proteins can be absorbed specifically. So you do a surface functionalization and immobilize it, and then you will see that the signal comes out. So virus, bacteria, they all can be quickly detected by using these type of biosensors. Many chemists were asked to develop cost-effective, accurate, quick diagnostics for understanding or detecting virus. At the same time, chemistry is also, the advancement of chemistry in these days is intrinsically linked with advancement in many other areas. One area is computation, fast computation, which we cannot even think about. These days, even a mobile can do very powerful computation. 10 years ago, only a mainframe could do. That is why computational speed is enhancing leaps and bounds. Along with that, newer tools such as machine learning. You don't detect one virus, you detect a million viruses. You detect a million compounds. You design not one vaccine, but a million vaccines. Efficacy can be tested. This by using powerful algorithms called machine data, big data analysis. Human beings cannot do this, machine will do it. So we need machine learning. Please remember that chemistry has already adopted these new advanced engineering technologies such as big data analysis, artificial intelligence in many areas. So it becomes very extremely handy when you have a pandemic to do all this analysis. That is why by leveraging the power of artificial intelligence and machine learning, chemists have come up with programs which will analyze millions of data. And eventually, you will also know wearable sensors. Mobile is very important for all these. So you can have point of care devices, and then whether it is the pathogen is in food or air or water, all that can be detected. So this is again an interesting aspect coming from chemistry. You can see now how pandemic has affected 2019, 18 April. This shows the flights, how many flights are moving all over the world. You will see so many, each of these small light is actually a flight. You will see thousands of flights going in all four directions. You don't know which is up and which is down, but otherwise they are all going. Please remember April 2019. Now you look at April 2020, most of these lights are diminished, very few flights. So this is one revealing example how the pandemic has affected our life. But predictions are there, within a year we will go back slowly. And these flights are again, the flights, there are plus things, mobility is very high, but there are negative things. Each of these flights generates so much of CO2 to the environment. In fact, the entire CO2 emission, if you look at it, maximum number of CO2 emission comes. CO2 emission comes due to various reasons. Some of them is due to energy generation, power generation, especially thermal and other things that we are talking about non-renewable energy generation. But transportation is something which is the second largest reason for CO2 emission. Each flight, 8% of CO2, not 8, I think 3% of CO2 is coming out only from flight. Travels some equal distance by car and flight, you will see flight generates much more CO2. So there are plus effects, but look at how the entire humanity got embroiled in this controversy. I cannot move out. I have been detected COVID, but I want to come back to India and die in front of my relatives, but I cannot move except there is a Vande Bharat flight. So you will see now, this is a revealing factor how the number of flights, the density of flights, everything got dramatically affected, because you can see the images from 1 year, 2019, so many thousands of flights. 16 April 2020, most of them have diminished. And please remember, each of these also is linked with temporary jobs, many jobs, air hostess, crew, then the people who facilitators, moving your luggage, screening them. So a large number of people lost jobs because of the pandemic. I mentioned you that pandemic is not something new. Our universe is 13.7 billion years old. And if you look at from the beginning, what we call it as the Big Bang, started with the Big Bang, and now we are here today. So in this period, the evolution of the entire universe, pandemic happened in many occasions. Of course, this we cannot even think about the initial time, because it's as good as a bigger pandemic. Because first is always physics, then chemistry, then biology, how it evolved. So you can imagine how many thousands of years. So after something like, universe is 13.7 billion years old, solar system is around 5 billion years old, our Earth 3.5 billion years old, and now, but how long? Few Homo sapiens are much younger compared to that. And our recorded scientific information is still younger. So even in these recorded years, I'm talking about 2,000, 3,000, or maybe even 5,000 years, there have been 15 pandemics. There have been pandemics even BC, 3000 BC, there was a big pandemic. How do we know? Because we go around archaeological excavations and we find that there is mass grave funeral happened. 1,000 people buried. 10,000 people, 5,000 people buried in China, and you do some carbon dating and you find that these have been, they died maybe 3,000, 4,000 years old. C14 dating can tell you. Now, please look at that. Now, compared to that, today, this pandemic is nothing compared to 15% of the population entirely wiped out. Something around 200 million years ago, an asteroid impact created so much of havoc. I'm sure most of you know about the disappearance of dinosaurs. So our pandemic has affected all our life, but much bigger pandemic happened earlier. That is why if you are a student of history of science and technology, you will not feel that sad. Okay, these are all again a way of life, part of evolution. Maybe we get a herd community. However, we look at each individual. We have to take care. We should not go out. If you don't go out, we are helping the humanity to flatten the curve of infection. And I mentioned you about chemistry's greater respect from society. Everybody knows what is hydroxychloroquine. All presidents, prime ministers, they know is something called hydroxychloroquine, which prevents lung failure. There have been controversy about this, and everybody now know what is mRNA-based vaccine, a cocktail of antibodies given to you, how COVID can disappear. So all of us, we know that there are 3 ways of stopping the pandemic. One means restrictions in free movement. Try to not to move as much as possible. That's why we have classes online, etc., etc. And then increase the large number of testing. Many countries, almost 100 countries, they are so strong in testing. And the testing, there are various methods of testing. Some methods are inherently more uncertain. And then hopefully the vaccine will come. Of course, if you don't get vaccine, eventually, as a part of evolution, we will have a herd community. Maybe 160% of the population gets affected. The virus will fizzle out because of what is called herd community. You can see electron microscope will tell you what the image of SARS-CoV-2 virus, what is the sheet, and chemistry we look at. What are the what is the composition? How many amino acids are there on the outer part of the virus? Professor Sabu Thomas would have mentioned about nanotechnology has provided us so much of solutions. We make different type of masks. Some of these are antiviral, antimicrobial, and personal protection kits. All these cases, chemists play a critical role. Many laboratories are working strongly on various fronts. How do we make better testing equipment to detect virus? Virus has the spike protein. We look at the chemical structure of that and find out something complementary so that it can be absorbed very strongly. So, or sometimes we design 3-layer, 4-layer mask in such a way that they don't close, they will not go through. And some of these things can come because of advancement in nanoscience and technology. 3D printing is a wonderful technique. 100 years ago, there was nothing called 3D printing. 3D printing means chemists play a role. It's not just printing alone, but you need inks. How do you make the ink? What type of ink is needed? Most of these inks will need a polymer, need a binder. That means you understand the structure and function, and everything starts in the laboratory, designing a molecule. In a similar manner, respirators, air purifying shields, incubation and disposable mask, all these cases, sometimes you need polypropylene, sometimes polyaniline, sometimes tetrafluoroethylene. So all these cases starts with chemistry. You can see that various projects are going on in the world. Sometimes they make virus antibody testing kits based on saliva, based on blood, based on sometimes the fluid taken inside your oral cavity, nasal cavity. You can see the objective is detect in a cheap manner, in a fast manner, with very small amount of sample, pathogens can be detected. Some institutions are focusing only on how do we design universal platforms for vaccines. Today, COVID-19, tomorrow something else will come. So is it possible to have a universal platform for vaccine? Any vaccine you want to develop with the same, with a minor tweaking, you should be able to do that. How is it possible? Because you understand the genome, replication and transcription of the virus. Again, I will not go to details. Some of you who are more familiar with the technology will be interested to look at what are there, what are the protein ribbons covering the virus. How do we introduce specificity on this? So vaccine development is again, lot of things are based on the basic chemistry, what we call it as the genome sequence, what type of amino acids are there. So 3 new vaccines have been developed specifically to elicit immunoresponse to the new coronavirus. One from China's CanSino Biologics lab, and another one from Oxford and AstraZeneca. I think India is more interested to get the Oxford vaccine. It is already manufactured in our country. Our Prime Minister says there is a plan to distribute first to doctors and healthcare workers, then to the general. They are making a plan. And another vaccine has come from Pfizer and a German biotech called BioNTech. This is based on the messenger RNA that synthesizes a crucial part of coronavirus, receptor binding domain. So receptors are there and the binding need to be specific for this type of a vaccine. So this again is almost ready, and a big US biotech firm called Moderna is supporting them. They have also come up with the virus. which Moderna's vaccine is called mRNA 1273. This is supposed to be 94.5% effective. 94.5 means, mostly it is effective. You will have very, very rare cases. Actually, FDA, Food and Drug Administration in US agency, they say that if a vaccine is at least 50% effective, then only you can use it. So now we are talking about 94.5% effective. So there is no doubt that it will come, and 30,000 people have been tested in phase 3 trial, and it has been approved. So Pfizer's vaccine, only the problem is that this needs to be stored at minus 20 degrees. That is a major deterrent for easy deployment. Minus 70 means you need liquid nitrogen. So how do you transport? You have to carry it in a liquid nitrogen container. This is one of the issues. While the other vaccine, the storage is not that critical. It can be kept at minus 20 degrees, and you can transport even at 2 degrees, 8 degrees. So with ice, transportation is easy. You will see. So we have at least 3 types of vaccine. One vaccine is highly effective, but only problem is transporting it needs minus 70 degrees. Other one is not that high. It is also roughly around 85 to 90% effective, but you have to transport it at minus 20. So I just want to tell you that all these are based on, these vaccines have been developed based on our understanding of chemistry. How many amino acids are there on the cover of the spike protein? How do you create these complementary binding interactions? And in a similar manner, chemistry has also spent a lot of time on developing protective measures. I mentioned to you about the face mask. Recently, people have made face masks by graphene. Graphene is nothing but, I'm sure all of you know, diamond and graphite. sp3 hybridized diamond, sp2 hybridized carbon, we call it as graphite. There is a big van der Waals gap between the plane, sp2 plane. But if you take only one carbon, one plane alone, we call it as graphene. Graphene is very interesting because of various reasons. One reason is that graphene has, in the plane, electron can move with almost the velocity of light. We call it as barometric transport. That means without any loss, electron can move. Mobility is extremely high. Mobility is, you will not get such mobility in any normal devices made out of semiconductors. Even gallium arsenide, you will not get it. So more importantly, it is almost like, there is no resistance at all. Ballistic transport, single electron devices can be made. So these are all unusual things about graphene. But graphene structure is also very interesting. Although we have an sp2 connection, graphene has got 2 types of carbon atoms. But at the edges, you will see the sharp edges. You will see that there are some unusual effects coming at the edges. Different type of edges are there on graphene. Sometimes you call it as armchair, sometimes you call it as zigzag edges, and they are all important for catalysis because they are all giving you active sites. But they are also important because sometimes they can puncture virus, puncture bacteria. That's why antimicrobial, anti-pathogenic properties are there more for this. So in any case, people have made mask out of graphene, controlled way of graphene-based composites. They find that they are much better. So somebody has come from a Korea group, laser-induced graphene. They found that the mask is 100% effective within 10 minutes in presence of sunlight. So photochemical generation of carriers on the graphene, which kills some of the bacteria. In a similar manner, nanotechnology has generated 3D printing, an amazing technology. You can even print a heart using 3D printing. In fact, this image is a heart made out of a polymeric material, biocompatible polymeric material, functions like a human heart. Almost same, volume same, aorta, is there, auricle, ventricle, everything is there in that, and you can actually use it for even doing a pseudo surgery. But the point is that chemistry has come up with this material. These materials are very important because you can even keep this in a human body as an artificial heart. So 3D printing has come up with many organs. Organ can be printed, and stomach is another artificial stomach, 3D printed stomach. So I am just showing all these to show that chemistry is no longer the old chemistry which is studied in schools and colleges. Chemistry is so dynamic that it has interfaces with many other branches of science and technology. Without chemistry, there is no biology. Please understand that all these cases, you will start with a small compound, sometimes a monomer, then polymerize, and then make this material as a composite and then print it. in a 3D printed heart, 3D printed human liver, 3D printed kidney. They are all in many laboratories. Some of these are undergoing advanced levels of testing. So what is the message? Chemistry has changed due to pandemic. The way we teach chemistry in the school, in the colleges, in universities, all that has undergone a big change. We miss the face-to-face teaching, direct personal interaction with students. But if you want chemistry to be taught with laboratory activities, one way is that you can have a virtual lab. The virtual lab concept has come up last 1 year in a major manner. For example, if your university or your college has enough financial resources, you can buy a virtual lab module. So virtual lab is a computer-based activity where students interact with experimental apparatus, just like you do in the laboratory. The lab, virtual lab, there will be an array of chemicals, barium chloride, ammonium chloride, HCl, H2SO4. You go to the mouse, click, take H2SO4 from the rack, put a big more H2SO4. All these are doing with the help of computers in your laptop or in your mobile phone. This is what is interesting. But the sound effect, you will see of course, smell effect you won't get, but sound effect will be there. You can even create an explosion. You will see nothing will happen. Okay, you will have no problem about safety. You can create a bomb. You can create what is happening at the center of Earth. So you can create what happens in the star. All this can be done. This is one advantage of virtual experiment. Of course, you will feel, the real feel will not be there, but many people play car games these days, same type of, many people play football games with the laptop. In a similar type of a virtual feeling you get. Actually, virtual labs are important. For example, Professor Brian Woodfield, who was a faculty member in Berkeley earlier, now he's moved to some other university. He has a module. I am giving you a site here. In fact, some of you can see this. This will be per head, you have to pay something like 30 or 50 dollar. Yeah, it is called Beyond Labs. If you go to YouTube and type Beyond Labs, you will see organic, inorganic, physical experiments can be done in the virtual laboratory. Only thing is this is a little expensive. You can see now, you have all the chemicals. Each chemical is there, beaker, then you have a separating funnel, you have a small balance. So you say that I would like to study this reaction, Reimer-Timer reaction. Then you take the compound, take from that, you have with a weight, find a weight, hit the balance, and actually you can do the experiment. Again, I will not go to details. I just want to show you that virtual lab is an opportunity where many chemistry students affected by the pandemic, they can buy this and do the experiments. Of course, there is a problem because this is quite expensive. So the objective is just to show you that you can buy this virtual lab. Little expensive per head. It must be around $30 or $50 per head. Just 1 second. So this is only one module, little expensive. Suppose you have 50 students, then 50 into $50. So this is expensive, of course. If you want to look at free virtual laboratories, the government has made many institutions. Can you hear me? Hello?
Yes, sir, it's audible.
Okay, and slides are visible
Yes, sir,
because
yes.
I went quickly to YouTube and came back. Okay, I hope it has not affected that. Yeah,
Yes, sir, it's visible.
Okay,
so
sir.
I just wanted to show you how experiments are done in a virtual lab with high quality, provided you spend money. Now there are free modules available. Government of India has created a virtual laboratory platform where if you just type virtual labs, you will get. IIT Kanpur has created a virtual lab platform where you can do physics, chemistry, and biology experiments. Biology, I'm not very sure. Physics, chemistry, and almost all engineering experiments can be done by using virtual lab. IIT Hyderabad also has virtual laboratory module. Quantum chemistry lab is available. Any of you register with your institutional address, give an email, and then you can do these experiments. Organic, physical, inorganic chemistry virtual labs are also available with Amrita Vishwa Vidyapeetham. Amrita Vishwa Vidyapeetham has a laboratory. For example, you can do some experiments I will show you. Molecular fluorescence spectroscopy, circular dichroism, and some melting point, boiling point. Some of these also can be done by physical laboratory. IIT Bombay has a special virtual lab. IIT Bombay website you go, type virtual lab, you will see again wonderful experiments which can be done by using this virtual laboratory. Just 1 second, I may have to stop sharing and start again. Otherwise, this is not coming to the full. Okay, I think I'm back. Yeah, so I've been talking about Ministry of Education or erstwhile what we call it as MHRD. They have also allowed any institution in the country to use these virtual laboratories. So IIT Kanpur, IIT Hyderabad, Amrita Vishwa Vidyapeetham and IIT Bombay, they all have virtual laboratories based on set experiments. They have limitations because it all depends on what experiment you can do. So you cannot tweak these experiments. But IIT Bombay platform is much better. So I suggest any of you, either chemistry teachers or chemistry students interested to do experiments, although you are in your house, you can access these virtual laboratories. For example, you can see now IIT Bombay Virtual Lab has these experiments: colorimetry, water equivalent, heat of neutralization, cryoscopy, viscosity measurement of a polymer, determination of viscosity of organic solvent, ebullioscopy, EMF measurement. EMF measurement is very interesting because you do a virtual experiment. Connect connect sodium with respect to sodium as an anode, where Na become Na plus is the anodic reaction. And you can have a cathode reaction of any other system. For example, you can have oxygen reduction as the cathode reaction. Now what you get is sodium oxygen battery. So the voltage you will get, EMF will be equivalent to sodium oxygen battery. Remove sodium to lithium. Put your mouse to lithium and bring it here now, lithium oxygen battery. So accordingly, the voltage will vary. So almost all galvanic coupled available in the periodic table. You can do alkali metals, alkaline earth metals, and on the other side, oxygen, sulfur. So the coupling become very easy. How does the free energy changes for the reaction? An electrochemical reaction, you can see that. So one experiment, one virtual experiment, the entire periodic table can be explored. How does the redox potential of this couple change? This is a wonderful opportunity because actual experiment we cannot even think about it. We can do only one experiment. Then by that time you replace sodium or lithium, somebody will touch water, there will be a bond, nothing of that sort. That is why this is interesting. In a similar manner, you can look at it now. If you want to do little more advanced experiments in the time of pandemic, I suggest that there is a very nice article in Nature Chemistry 2020, what is about how do we do experiments in time of COVID-19. But this is an advanced level. Either you are doing a BSc or MSc chemistry, then you can do that. You need certain things. Some of these are commonly available. For example, if you must have a smartphone, or at least you should be able to take pictures by the phone. Smartphone with a camera, then clips, digital thermometer, kitchen scale. These experiments are interesting because in the time of pandemic, chemistry can be taught in a wonderful manner by doing such interesting experiments. If you don't have this, best way is go to the kitchen. You will see wonderful experiments. So what we miss in the laboratory can be carried out in kitchen, provided you have a basic understanding of acid-base chemistry, what is the food, and of course, I think your parents should allow you to enter the kitchen. Sometimes, they may think that when you go and you say, I want to do some chemistry in the kitchen, then it's up to you to decide. You can start very basic level of experiments using electricity generation from pickle. You can have...
Sir, excuse me, sir. Shall I interrupt you?
Sure, please.
For a minute. Sir, your slides are not seen.
Not visible?
No.
Okay, just 1 second.
Okay, sir.
Maybe I'll have to close and share, then it will be okay. So when did my slides disappear?
Sir, after
Hello?
you just
When you
switched back
rejoined.
to the presentation,
So, okay, the virtual
5 minutes
laboratory.
before.
And how long I need to talk? You can also tell me if I am overshooting my time.
No, sir, it's okay.
Okay.
No issues.
Yeah. Can you see my slides now?
Yes, sir.
Okay.
Visible.
Yeah, so I have been talking to you about virtual laboratories. Virtual laboratory is a very interesting concept because everything is based on computer or a laptop or even a mobile phone. So students interact with the experimental apparatus and chemicals by using a computer interface. So no physical activity, but you will be able to do experiments. So to prove this, some cases you can do it in a fantastic manner, but very expensive. I showed you one example from Professor Brian Woodfield. He has a company. He has developed modules for physics, chemistry, and biology. Of course, it's expensive and based on number of students. So if you want 30 licenses, then it could be quite expensive. What is the alternative? Ministry of Education or S2I MHRD has created a platform for virtual laboratories. Some of our institutions have contributed to virtual laboratory. IT Kanpur has many experiments in virtual laboratory, especially chemistry. One of the fantastic modules is ultra fast laser lab. So ultra fast laser lab of IT Kanpur allows you how a pulse laser falls on a chemical, how isomerization happens, what are the energy transfer pathways, how long, all that can be looked at it. In a similar manner, IIT Hyderabad has a quantum chemistry laboratory where virtual experiments can be conducted. You can link with the reusable, light emission, that can be under electronic structure, Huckel molecular orbital theory, all that can be understood by using the quantum chemistry lab. Amrita Vishwa Vidyapeetham has only physical inorganic chemistry laboratories, and IIT Hyderabad has also something more on molecular fluorescence spectroscopy and physical laboratory. I like IIT Bombay because they have done they have given a broad landscape of chemistry experiments. Beyond this, if you want to do advanced level of experiments, you can also see one reference given here in Nature Chemistry 2020. There is a very interesting article about how to do experiments in a virtual laboratory. But you need some essential things such as you need a mobile phone with or a smartphone with a camera. Then you can make your own paper-based microscopes. You need a digital thermometer, and then you can take weights of materials in a plus or minus few grams or sometimes even kilograms, and a laser pointer, and then a handheld pH meter, digital multimeter, and then you have a set of advanced level of experiments can be done. Even that is not available, then I suggest that students during the time of pandemic can go to the kitchen and do a lot of experiments. If you want to do your kitchen as your laboratory, you need to have a basic understanding of the type of materials available in your kitchen and how do you link with chemistry. That link comes by experience. Sometimes you are a passionate teacher, this comes. Sometimes the experiments are very simple. You can generate electricity from pickle or lime or a potato. You can make an air cannon. Air cannon is very easy to work. Or if you have a small, I would say that you have a small access to petrol from a two-wheeler. No, I'm not talking about large. You please take only 5 ml or 2 ml. Don't burn the kitchen and tell that, I am responsible. No, you take only a few drops of petrol, put it on a can and just light. You will see, you can see rockets going up. The can's top alone will fly. So this is like, sometimes in chemistry demonstration, we take a balloon and just burst it to create the crackling sound. As long as the halogen is extremely small and we don't have an explosion, it is fine. So chemistry, the interesting aspect of chemistry is you can create fires, you can create explosions, you can create crackling sounds, all that in a controlled manner so that there is no damage. Because this is also a way of illustrating safety to the students. So it is for us to make sure that safety norms are practiced in all these experiments. The point is that, yes, you have a potato has starch, you take milk has casein. Now you take milk for 2-3 days and then you will see bubbles coming out. Of course, you can't drink it because already spoiled, but you will see the fat particles coming out. Now you can say that milk is not a solution. It's a heterogeneous. How do we separate out? Similarly, you can take some cardboard paper, do a chromatography with various types of inks. You can take, if you have a red cabbage or beetroot, extract that, and this could be made as a pH paper by you. Take, for example, hibiscus flower, shoe flower. Take the flower and paste it on a sheet of paper. You will get an easy litmus paper. Put a tamarind, you will see red color. Put some sartan, you will get base blue color. So this is a way of doing experiments. This is unstructured, but you can do it with your knowledge of chemistry in a structured manner. If your mother is brewing coffee, just go around, look at what is the stage where coffee brewing means you have to take from coffee seeds. When you do coffee seeds, heat it at 200 to 300 degrees, nice aroma comes. What is the aroma? What is the origin of this aroma? Now you pyrolyze it. What are the chemicals coming in coffee and tea? So these are all very interesting. Even to bake a cake, look at the chemistry. Chemistry involved in even simple bread itself, you look at it. How the bread is formed. Take a maida flour, you can mix with yeast, fermentation, or if you are interested to make a wine from ginger, take a ginger juice. What is there in what type of gingerbread, what type of alkaloids are there? This is what we are talking about it. And this chemistry is also wonderful to do in the kitchen because sometimes you get bonus. You may make a chocolate, you may bake a cake and eat it, and you may even make an ice cream. Look at the composition of ice cream, how physical changes as well as chemical changes, what type of phase transition happens. This is why I think that pandemic should also allow you to be aware of very interesting aspects of culinary chemistry, or sometimes people call it as gastronomic chemistry, because it gives you very nice aroma, nice sense of taste as well as smell. Onion, what type of compounds are there in onion? Or garlic. Why garlic is considered as something which can prevent or which can attack the pandemic virus? Many people make rasam with a strong amount of ginger and garlic. Garlic has some compounds, allicin, allicin. So these are all important compounds. This similarly, you can always take a lemon. If you have all these are easily available. You don't have to go to a chemical supplier and buy chemicals. Whatever is available, baking soda, washing soda. If you know the structure of these chemicals, you can design new experiments. Some of them will be totally new experiments because sometimes ice cream itself used. Imagine. Understand a little bit what are the things in ice cream. You may have to have what type of chemistry is there in that. Then you can think about new innovations. Can I make a two-dimensional ice cream where ice cream is not three-dimensional? It is not, ice crystals are not distributed in all directions. Ice crystals are confined in two dimensions, next layer, next layer. Or how do we change the of ice cream? Texture is very important for taste. Sometimes if you keep an ice cream in a freezer and imagine power is not there 24 hours. When you come back, ice cream is all melted. Now, after power comes, you will not get the same taste because it's all gone. The what you call it as the thawing of the ice cream is the one which gives that fine taste. That is gone. So after melting and then again recrystallize, you have to do in a fine way to disperse ice crystals. So the taste will never be there. That's why just please look at this as an opportunity. Since COVID doesn't allow you to go to your chemistry laboratory, you can go to kitchen and tell that, look, I want to make a nice ice cream today, which nobody has made in the world. Provided you understand what are the components in ice cream, you have to experiment by changing some of the things. Maybe the water is there, you cannot change much. Fat content you can change. Protein, of course, different type of protein. Sugar you can change. Sugar can be slightly caramelized. So you will see, or in some cases you can put, instead of sucrose, you can put levulose, or you can use fructose from honey. So these are all ways of doing experiments and finding that, look, something you are doing. So stabilizers and emulsifiers, again, you have, there are materials, but I think you may not be able to much change. But in certain areas, you can do innovation. So normally, you want to make this, the air bubbles in ice cream is very critical. Air bubbles are essential to create a three-dimensional structure, but there are ways of making in such a way that you can make it 2D so that it doesn't collapse. So when you talk about ice cream, there are many things about it in ice cream. Mono, diglycerides, you can make ice cream with a little bit of cocoa powder. So you will see now, destabilizing the fat, coalescence of these colloids, creating a branching network, all these are important to contributing the taste. How do the globules of clusters are supported in the air bubbles? The air bubbles, if it is very big or very small, the texture and the taste will not go away. So by whipping, these air bubbles should be distributed uniformly everywhere. And then the freezing should be done in such a way that you have around 20 to 50% of air bubbles. Then you will see, yummy, ice cream is so good. So if the air bubbles are less or more, you won't get that type of taste. That is why the thawing is very important. Many of the recipes available, you will see very great importance given for thawing. And there is very interesting phase diagram rule, which is important for you. So when you look at the chemistry of ice cream making, changing the compositions, if you look at, there are books on food chemistry. Food chemistry books will have a section on ice creams. If you look at it and understand what are the chemical interactions, how many types of sugars are used, what are the fat globules, how do we control the air bubble size, all this can be done in experiments by changing the temperature, changing the concentration. This is why I'm telling that, look, if you are a chemist, there is no barrier. You, wherever you are, it is possible for you to innovate. Put a little bit of beetroot juice coming out, very nice color. And now you have to understand what is coming out, what gives. So this is why you also have to control temperature very critically. You vary the temperature. If you have a thermometer, you can always set the temperature -20, -10, -30. In fact, one of the nice experiments you can do in the laboratory is, if you have liquid nitrogen, put it in ice cream and see how the texture changes. Liquid nitrogen you can even drink. You have got a very hot, boiling coffee and you want to drink one way, put liquid nitrogen, drink it. Nothing will happen because it's nitrogen essentially, which we breathe. So these are all the things which, due to pandemic, you are forced to be in the kitchen and you have innovation channels available for you. This is why ice cream itself is one example, but you can have several such examples. You know, instead of ice cream, you can talk about making a chocolate with the cocoa powder. How do we control the sugar to cocoa ratio? Ice creams, again, variety of ice creams. You can see this is only to show how which children love mostly chocolate and vanilla ice cream, butter, other. So just to show that different type of ice creams are important and the chemistry is interesting. Imagine you have potato or only sweet potato. When you potato and sweet potato, you can actually steam it or you can burn it. It's not only potato. Any of these material which has a class of carbohydrates or starch. At the same time, you have some sort of proteins. When they bake them, baking of them is very important. Even a small piece of bread, you toast it, you get very nice brown color. Why does the brown color come? Due to a chemical reaction. So this is a very interesting area to understand more on chemical reactions. Imagine you take sweet potato. Sweet potato you fry or you, let's say, put it on a 200 to 300 degrees, a very nice smell comes out. What is the smell due to? It's difficult for us to look at one smell because human nose or animal noses, we are endowed with so many smells. We can detect so many smells with very, very parts per billion sometimes. Human excreta is nauseating to all of us because of hormone called scatol. Even parts per billion of scatol gives you so much of offensive smell. At the same time, parts per billion of many chemicals give you very nice smell. One, there is a compound called lemonol. Lemonol, 10 ppb gives you very nice lemon smell. But this is an isomer. If you take the D isomer, if you take the L isomer, it gives you orange smell. So same compound, D gives you one smell, L gives you another smell. Similarly, sweet potato, if you burn or roast, you get around 29 compounds coming out from that. All of these are organic compounds. The most important of them is 2-acetylfuran. 2-acetylfuran gives you a peculiar smell. This smell is something which is a very pleasant smell. The smell detection itself is interesting because every time a receptor comes, something like 2-acetylfuran is bound on the olfactory epithelium. It elicits some generation of neurotransmitters in small amount of dopamine. And whenever you get addicted this small, the primary culprit is dopamine. So please remember that there are several neurotransmitters these days. Chemists also develop biosensors for these neurotransmitters. And you are there is something called runner's high. If you run 20 kilometers, 10 kilometers every day, one day you can't remain without running because there is a small amount of dopamine get addicted. So you get addicted to running. Today, 10 days you run 3-4 kilometers, 11th day, very difficult for you because you have to run. When you run, small amount of neurotransmitters, and the dopamine is responsible for you to get this addiction, just like cigarette smoking or drinks or drugs. The addiction primarily due to a small amount of neurotransmitters released in a particular part of our brain. So you can even look at chemistry of these neurotransmitters, again very interesting. Now the point I want to tell you is that acetylfuran and acetylpyrrole is there, which gives you the characteristic smell, an addictive type of smell when you roast sweet potato. Similarly, there are many other foods. Some of the foods when you roast, almond-like smell comes. Sometimes you get, caramel. All these are chemical compounds. What are those compounds? What are those chemicals? That's also very interesting to look at it. Smoky, flavor-like, fruity, all these cases. But only important point is there are hundreds of such organic compounds. Aroma. When you make a simple tea or coffee itself, you will see hundreds of chemicals responsible for the overall aroma. It is very difficult for us to separate them, but now tools are available, big data analysis, artificial intelligence. Using that, you can separate each of them. These days, we have artificial noses available for decoupling most of these gaseous aromatic compounds. Similarly, there's a very interesting reaction called Maillard reaction. Maillard reaction is responsible for yummy taste of pizzas and grills, whether it is grilled fish or grilled chicken. The primary chemical reaction responsible is the amino acid reacting with the reducing sugar to give this browning of food. So the browning happens due to chemical reactions. Sugar has glucose or any other form of sugar, reacts with an amino acid and you get a glycosylamine. The glycosylamine is responsible for this browning color. So if fish is fried, not to the real extent, and you will see the kinetics of this reaction is responsible for this nice smell as well as the color and taste. So Maillard reaction is a very interesting reaction. There are classes of Maillard reactions. In fact, it's not one reaction, there are several compounds. Maillard reaction produces hundreds of products. Small subset of these contribute to flavors and aroma. There is no one-to-one correspondent, but some of the groups are very important. So when you walk in the road, you say, oh, there is fish is fried. That comes because trace amount of chemicals. Some of these are pyrazines, some of them are alkyl pyridines, and they come together and furans. They come and your nose can detect. So fish is being fried, chicken is being fried. The chemicals generated are different. You can you will know whether it's fish or chicken. Of course, you have to go and eat it. That is a different matter. But please remember that this is again an area where chemistry plays very interesting. We are talking about non-enzymatic browning. Browning can also come during fermentation. That browning is different. That is because of the enzymes. So non-enzymatic itself, you can see gate to Maillard reaction. Maillard reaction is the one which gives you chocolate becoming brown, toasted bread becoming brown. Sometimes when you talk about chocolate, there is also a very interesting compound in chocolate, which is important. Call it as God's food. Chocolate has been a great addictive food for humanity from the beginning, coming from choco. But the compound which is responsible for its particular flavor is called theobromine. Theobromine has no bromine. So sometimes chemists name it in a funny manner because it's not the chemist who named. It came from historically these names came from how human beings separated chocolate from cocoa, how they prepared, etc., etc. Theo means God. Bromine is actually food. So theobromine is very interesting compound. Structure is, you can look at the structure. To nitrogen here, another nitrogen. This is NCS3. Here there is also NCS3. It is there in cocoa, 10 to 10%, and chocolate has this compound. Higher concentration of theobromine gives you dark taste. So milk chocolate will have more milk, and that is why it is sweet. So tea and coffee powder also has got this compound called theobromine. Theobromine has no bromine, unlike people will. Theobromine means people think that there is bromine. Caffeine, actually, suppose some of us like coffee and tea because that goes to the human liver, and caffeine is metabolized into three products. Paraxanthine, structure you can see how similar. Theobromine and theophylline. Theobromine is something which is very peculiar. If you get theobromine is the one which is responsible for the melting of chocolate in our mouth. Now, so I have been talking about doing chemistry in the time of pandemic. Pandemic has come and affected all of us. Pandemic is only one major disaster, but there could be several such disasters for us. Chemists have a job of offering solutions to these type of disasters. How much more time I have? Hello?
Sir, 10 to 15 minutes.
Yeah, so I just wanted to tell you because my topic about the pandemic part is over. I just want to tell you something general about chemistry, and within 10 minutes I would wind up. So
Yes, sir, please.
pandemic is one situation where chemists have come out of solutions. Solution in terms of mask, antimicrobial, antiviral mask, using even 3D printing, interfacing with computer engineers on using metadata analysis, and also personal protection equipments. Then chemists have come up with detection mechanisms, biosensors, how rapidly, how cost effective virus can be detected by a variety of techniques, sometimes using color, sometimes using chemicals, sometimes using a receptor binding, specificity of the binding. Third aspect is about the vaccines. Sometimes we have an ambitious platform, ambitious target of making a generic viral platform, vaccine platform. That means today this virus, tomorrow something else comes also, the vaccine will help. So these are all activities going on all over the world, and chemists fight with this with this virus using these type of rules. So you must also look at in a broader perspective. Chemistry helps us to have a better world, definitely, and much more sustainable environment. Humanity's challenges for next 50 years or even 100 years, you look at it, war with death is a major aspect in chemistry. War with death means how do cell death happens? What type of cells? Certain cells will have cell death. We call it as apoptosis. certain cells will never die. So how do we delay cell death? Can we become eternal? Look at that, average lifetime 50 years ago was much lower, maybe around 40 or 50, then become 60, 70, 80. So as we progress, our average age increases. How can we, there some human beings live 100, 110. So can we make it 150? Can we make it 160? Can we discuss what is it that limiting? So this is again an area where chemists contribute enormously. Google has a major project with finding out how do we delay senescence. We are talking about brain. What happens during aging? Of course, cells, bones, all that will undergo aging, but some of these are reversible, some of these are irreversible. But those aspects can be removed or augmented. This is what is a major program in the world, war with death. How do we delay? Energy is another major problem. Energy, as we progress more and more, we need more and more energy. But the way we make energy is still not acceptable. We want to make energy without creating any adverse effect on the environment. In particular, CO2 should not be generated. So energy generation technologies are classified into three: carbon neutral, carbon negative, carbon positive. We have been so far making carbon positive. That means any energy you generate, a lot of CO2 will come out. That was not acceptable. So we moved to carbon neutral energy technologies, renewable, solar, wind. But in future, we must be using carbon negative. While generating energy, CO2 must be absorbed. So these are all major problems: energy, water, food, environment, poverty, terrorism and war, disease. COVID is one example. So all these problems, wherever we have, we need to come up with solutions. Globally, you can look at the population now. We have around 7.7 billion. It will become 9.7 billion by 2050. India itself, we have around 1.37 billion people now. It become 1.6 billion soon. Our government has a plan to aspire a 5 trillion economy by 2023, and many things are happening. 50 years ago, our lifestyle was like this, nothing. You need how much energy you need per day? Very small amount of energy. Get up in the morning, go to the field, come back and sleep. Maybe less than even 1 kilocalorie. Or from that, we go to a big city where we have so many vehicles. Even now, India has something around 20 vehicles per day, per 1,000 people. 20 vehicles per 1,000 people, and it is increasing. After 5 years, you will see 20 become 50, 60. So too many vehicles are coming out. And this is one reason where we wanted zero emission vehicle. Look at a place like Mumbai. People, 24 million people in 2019. So much a huge population. So we have big cities coming up. One side in India, Delhi with 29 million people, second most populous. Soon it will become the most populous city in the world. Right now, Tokyo is the most populous, but soon we will overtake. Delhi will overtake Tokyo in terms of the most populous city. India will overtake China in terms of the populous nation. Both are going to happen. And then we can see many cities, big cities. A big city, if it crosses 15 million people, it is called a mega city. India, you look at full of mega cities. So these are all peculiar problems for India. So much of traffic, so much of waste is generated. We can imagine this is in Jakarta, but I'm sure if you travel in India also, you will see so much of disasters, plastic lying. So sometimes you wonder, because I mentioned you society's wrong perception of chemistry. They say human beings or scientists have made all this. Global temperature, global warming. We had hurricanes every time coming up. So much of industrial pollution. Even now we are not safe. Delhi and all that, people don't even come out. Supreme Court has put so much of strictures. You should not come out at all. So one side you have development, other side you have a lot of problems. If you look at our globe from outside, in a satellite, you will see these are the images. India has brown patch. Africa has brown patch. All the places are okay. So much of pollution. China has made huge purifiers. One big city, you can purify air by using this mega 100-meter high air purifier. This has come recently. India is still waiting. India also, you will see, soon it will come out. Our pollution quality index is so poor compared to many other countries, partly because the way we make energy. So there are a lot of things related to that, and chemists play a critical role even in this. For example, India has proclaimed to the whole world that we will reduce carbon 25%. 2020 has now become 2022 due to COVID, but we agree that global warming should not be more than 1 degrees. All countries are planning. India has done some impressive things. We first put a target of 175 gigawatt only by solar and wind, renewable energy. 100 from solar, 60 from wind, 10 for small hydro, and we have been able to achieve it. In fact, now India's contribution for renewable energy is 24% of the total electricity. India generates 370 gigawatt of electricity. India generates now. Out of that, 24% comes from renewable, solar and wind, and still it is increasing. So one side, many other countries, if you look at Kyoto Protocol and all that, you agree. US has pulled out. Now probably after the new president, US might play a more proactive role. Trump has pulled out from this Kyoto Protocol. And similarly, Australia also pulled out. So now we hope that there will be much more from US side to make sure that the global warming is less. So global challenges, one of the major issues is carbon emission, and energy is primarily responsible. India has an ambitious program. India is planning charging stations, electric vehicle. In fact, our Prime Minister last week told that we will meet our goal of 175 gigawatt of renewable energy well before the target 2022. And India is now aspiring to make 450 gigawatt by 2030. This has been told by our Prime Minister just last week in a G20 summit. So our solar and wind, we are doing very well. We will continue. There are problems of storage. So chemists should come up with more important problems of storage. I will not go to details. Many innovations are needed for hydrogen economy. Fuel cells are very expensive. We need to make cheaper fuel cells by using electrocatalysts, platinum-free fuel cells. We still don't have good batteries manufactured in the country. Somebody in Tesla or some people manufactured about India, we still don't have lithium batteries. And we have problems about electric vehicle. We know how, but most of these problems are related to materials, affordable materials. We know how to make all these materials, all these battery components without cobalt, etc., etc. Again, I will not go to details. You can see how the cost of battery has come down dramatically due to chemistry. Primarily chemistry, because chemists have come up with very fantastic materials. Some form of graphene which absorbs lithium, some form of tin, silicon. They will take lithium. Lithium has very high energy density. So you can see now all these are essentially due to materials and chemistry. We have a national mobility mission. India wants to have all vehicles electric by maybe 2030. So you will see sales we expect. There are several issues related to electric vehicles, but government is keen that we must have electric cars, electric vehicles only, electric trucks, because zero emission. Each state government has a plan. Again, I go to details. So let me tell you that, let me summarize. I've been talking about chemistry. Chemistry is a great enabler. It is diseases, all branches of chemistry is important for society. You can talk about medicinal chemistry, pharmaceutical chemistry, you can talk about materials chemistry. Chemistry is all developments. You will see two roads coming very clearly last 5 years, last 10 years. One of them is materials, wonderful materials, biomaterials, bio-inspired chemistry, materials chemistry in terms of something you can even go and touch the sun, very hard, super hard materials, very strong, ultra strong alloys, all these understanding of chemistry, because all these materials are made out of atoms and molecules, composite materials. So atoms and molecules is the building block. With respect to that, sometimes you make supramolecular structures and then you make the actual material. So material is a vibrant activity of chemistry. Other one is bio, drugs, designer proteins. How do you make a surface in such a way that only coronavirus absorbs? You look at the spike protein structure and make a complementary binding. So this is another area. So the entire chemistry you can see channeled into one for materials, other one for bio. These are bigger things. Of course, many other applications are there. Managing the environment is important. Carbon footprint is important. New type of energy storage, redox flow batteries, lithium, sodium, magnesium, rechargeable batteries. They all need new materials. And materials means starting from chemistry point of view. Wearable electronics, you will have a shirt which will change with color, which will, on raining, if it rains, it will already become hydrophobic. There will be wearable electronic devices to check your blood pressure, diabetes, sugar level, heart rate, all that using these wearable electronics in the shirt. These are all innovations which we expect. Lithium oxy, lithium sulfur batteries will be available, rechargeable batteries for the next generation. Similarly, redox flow batteries, flexible supercapacitors, two-dimensional materials. Two-dimensional material is an area where I do a lot of work. Graphene, phosphorine, styrene, bismuthine. These are all two-dimensional materials. That means only one plane. They are important for electronic application, important for energy storage, important for electrocatalysis. So I did not talk about my work at all, but we do some work in those areas. Carbon dioxide reduction is very important. You will see. So these are all technologies which are expected to be rolled out in the next 10 years. Cheaper solar fuels, affordable solar materials, artificial photosynthesis, hydrocarbon generation and storage, zero effluent processes. You will see chemistry is a great enabling science, central science, we talk about it, which is very clearly revealed by the statement of Linus Pauling. Linus Pauling is one of the great poster child of chemistry. He got Nobel Prize in chemistry, and also he got Nobel Prize in peace. But he was always against nuclear bombs, anti-nuke person. So he had several difficulties. His passport was taken back by US government when he was about to go for a conference. He was a professor in US, but he was always fighting with his wife, who was also a very well-known person who fought for banning all nuclear activities. So his statement, I feel sorry for people who don't understand anything about chemistry, because chemistry is such a powerful force, so important for sustainability of the environment. So if people don't know chemistry, I feel very sorry for people who don't understand anything about chemistry. They are missing an important source of happiness. This is what Linus Pauling has mentioned. And I also mentioned to you about Richard P. Feynman. He always says that every aspect of world today, even politics and international reactions, is affected by chemistry. So with this, let me thank all of you for your patience. When humans started dreaming of living in Mars, thinking they had already conquered the Earth, till they imagine tiny invisible microbes can invoke their powerlessness, until mankind starts respecting the power of Mother Nature, to whom we all surrender inevitably. Because this is also a time of microbiome where when human genome sequencing was done, we thought that we understood everything. But no. How many cells are there in a human body? More than that, 100 times more of microbes are there. That is the reason why these are all important. So I hope I have been able to talk to you about the relevance of chemistry. One side we spoke about pandemic, how many type of research activities are going on in the world to fight with the pandemic. At the same time, how pandemic has disrupted our academic activities, research, teaching, laboratory courses, but there are solutions. I spoke about virtual lab. I spoke about doing experiments in the kitchen to have a deeper insight on chemistry, especially about the normal food we take, maybe cooking an omelette. All these cases, interesting chemistry happens. You must look at this and understand, because chemistry is a way of life. I stop with a quote from Oliver Sacks. Oliver Sacks is something which I like, because being a neurologist, born to doctor parents, still his fascination was always chemistry. Although he was a neurosurgeon, found a lot of medicines for neurological diseases, his primary passion was chemistry. Similarly, born Oppenheimer. Oppenheimer is also a person who was a theoretical physicist, but his primary love affair, affection was always with chemistry. So I quote, as a chemistry mad boy, I devoured books on the history of chemistry, evolution of its ideas, and the lives of my favorite chemists. Chemistry had for me a historical and human dimension too. This is Oliver Sacks. So I have given some references. I showed you one YouTube video about the free video about the virtual lab by the one professor, but these are also, you can see There are many small videos about relevance of chemistry. Some of these are from American Society, freely available. You don't have to become a member. You can look at it. With this, let me once again thank the staff from Marthoma College, Chugatara, especially the principal and the faculty for giving me an opportunity, and I would be happy to answer any questions you have. Please type it in the chat box, because sometimes, since our distance is so far, pronunciation can be sometimes a deterrent. Thank you all.
Thank you,
Hello.
sir.
I hope I have taken more time than you expected. Hello?
No, sir.
No, okay. I was worried whether I have taken more time. Maybe you have another lecture, I don't know. Let me stop sharing. Then I can see the chat box. Hello?
Participants, if you have any questions, you can raise it on the chat box.
Please type in the chat box whatever questions you have on anything which I spoke. Or you can unmute and talk. Or raise your hand, any of these modes. I think something in the chat box. I think in the chat box, I only see a feedback form.
Yes, sir. There is no question in the chat box.
Okay, so maybe they can unmute and ask. Identify your name as well as what do you study, then it becomes easier for me to answer. Or maybe you can ask first questions from faculty.
Sir, can I have a question?
Please, without question, no seminars, no discussions, okay? At
Sir,
least I expect 20 questions from all of you, I expect. Yeah, go ahead.
sir, can you just tell me about the perovskite solar cells and plasmonic solar cells?
Yes, I can tell you. Solar cells, essentially, you understand that light falls, and a cell means light falls and you generate a voltage. Not like a photovoltaic. Photovoltaic means, like a silicon photovoltaic cell. But here, what happens is that the interface is very important. Perovskite means a structure. Perovsky was a German, as a Russian mineralogist. So AbO3 type of compound. So perovskite solar cell is very important because many people recently they found lead-based compounds, tetramethyl, tetraethyl, lead-based compounds. They found that this gives you very good efficiency as a perovskite. You can generate excitons, make them long-living, and then get the electricity generated by the solar cell. So one side you had a dye-sensitized solar cell, DSSC by Gratzel and company, but that is saturated, and that is the time where new type of solar cells called perovskite-based solar cells came. Many people are working on the perovskite solar cells. There are problems such as degradation. There are problems such as, lead is always a problem from environmental perspective. So people are trying to make lead-free perovskite solar cells. Very promising area of research. Plasmonic solar cells, you need to understand what is a plasmon. And then plasmonic solar cells are solar cells where the plasmon, actually you need to understand what is a plasmon. Plasmons are collective excitations on a material. In fact, you make a gold or silver nanoparticle, you will see a surface plasmon band. So close to the Fermi, I don't know why have you studied some solid state physics?
No, sir, but I know about plasmons.
Yeah, so surface plasmons, when you look at it, if you imagine a free electron model of metal, you have a sea of electrons. So when an excitation, when an external perturbation comes, collective mode of excitation happens. Collective mode of all this is what is called surface plasmon. Okay, so they can interact with light. Now, so plasmonic solar cells will increase the solar cells by virtue of the interaction of plasmon. I think again this is what you call it as the detailed discussion based on that. That is why I mentioned that your background accordingly I can talk about it. But no doubt that they are very important. Plasmonic solar cells are coming up as a emerging area recently. Even in our institute, there is one Dr. Janardhan Kundu who works on plasmonic solar cells. And
So it's not commercialized.
sorry?
It's not commercialized.
No.
Oh.
Even perovskite solar cells are not commercialized.
Okay, sir.
Dye-sensitive solar cells you will get sample, but they are not, again, the efficiency has reached a saturation. So what is commercialized is only silicon solar cells.
Yes.
Okay. Organic solar cells, there are companies which will sell you a small pieces of organic solar cells. Efficiency may be 3 or 4%, but they are very cheap. You can do it on a, what you call it as a inkjet printing of that. Okay, with some organic materials. Of course, there are organic solar cells. There some TVs are also available, but very expensive.
Yes, sir. Thank you.
Does that answer your question?
Yes, sir. Sure.
Okay, thank you.
Thank you, sir.
Sir, connected to that one, shall I ask one question, sir?
Yes. Go ahead, Dr. George.
Sir. Sir, actually, it's regarding the hybrid of solar cell as well as LED. At the daytime, we can use it as solar cell, and in the night time, it will act as an LED or a power source from we can catch the light.
Yes. So low power application this could be used. You won't get much power density with all this.
Yeah.
Okay. If you want to get higher power density, you should also incorporate a supercapacitor along with that. They are much more important for storage.
Okay, sir. Okay, sir. But can we expect more efficiency in the coming days in the same?
I don't work in that area, but I don't see any great change coming.
Okay, sir.
You will see only incremental improvement in efficiency. One of the problems is degradation of these materials. Okay. Life is limited, and degradation products are lying there, that efficiency come down. Even I'm sure great programs are there in the country where they want to improve, they want to stop the degradation. This degradation is also due to light induced. So there is focus more on diffuse light. That means you don't apply very strong light. In the room also you get sometimes diffuse light. You don't have to go to the terrace or rooftop to get high intense light. Okay, because degradation is more there.
Okay, sir. Sir, in between, your face is not, we cannot see your face, sir. Actually, camera position.
Oh, is it now?
No, sir. It is only your right hand I can see.
Oh, is it? Maybe cameras moved.
Sir, actually, I can see.
You can see. Oh, okay. Maybe then camera one of the PCs. So you are all in various locations, right?
Yes, sir. Yes.
Sir.
Yeah, maybe that direction.
Yeah.
So I still don't see any questions in the chat box. How many students are there? Many masters?
Yes, sir. And these master students are also there.
And they must ask questions. Okay. You can otherwise send me my email.
Okay, sir. One more question, sir.
Yeah, please.
One more question. Sir, regarding the present research in India about the battery, because so many electrically powered cars are coming. Even our Tata is released the Tata Nexon electrical vehicle, and Hyundai is also releasing. So, what about the research in India, progress of research in India about the battery?
See, I'll tell you, because all these Tata, Mahindra, all the automobile companies, they don't trust Indian researchers. Okay, so they get always cells from outside. For example, Mahindra signed an agreement with LG to get batteries for next 10 years. Okay, so Maruti also has signed with a Korean company. India, we have technology. India has at least three, as far as I know, three technologies available. One from ISRO. ISRO has demonstrated their capability to make lithium batteries. Then we have a technology coming from DST side called ARCI, Chennai, ARCI Hyderabad, and they have a Chennai center. And then there is also technology coming from CSIR, 2 or 3 labs together. So all these three technologies, they know how to make lithium batteries, but I believe they are either expensive or the reliability level is not strong enough to convince the India industry. IIT Bombay also has cell making ability. IIT Hyderabad, every IIT there is a program, but most of the IIT groups, they make this the cell level, not huge battery, and then they test it. They may publish publications and papers and patents, but they don't go to the technology level. IIT Hyderabad has a startup inside. IIT Bombay also there is a startup. Delhi has a startup, but they are all small activities. So if you ask me, industry is concerned, industry always takes cells from outside. Government is little ambivalent. They say that initially all electric vehicles you can get cells from outside, but maybe after a period of 10 years, ETI says India should manufacture. So Tesla itself has considered India as one of the hubs for manufacturing. I really don't know because it's all going in a very slow rate, and what is written in newspaper most of the time is not dependable. Reports will come, just some photograph telling that MOU signed and we are starting a 200 megawatt battery manufacturing plant, etc., but nothing happens. So recycling also, NITI, I will emphasize for activities. Isolated research activities are there everywhere. I'm sure every institute, every big institute, national institute, IITs, you will see research activities in supercapacitors, batteries, and fuel. Even some of the colleges they are doing good work, they publish. This is the Indian scenario. Okay?
Okay,
Dr.
sir.
Joe?
Yes, sir, I am here.
Yeah.
But
So
why we are not promoting this, sir?
Why we are
not promoting to?
No, it is not promoting. It is like, we can't have forced marriages. Industry, whether it is Tata or Mahindra or any industry, Hyundai, Nissan, they all have their own research activities, okay, in a small level. But Indian government's idea is that Indian government says that we want electric vehicles. First, let the vehicle come in India with imported batteries. After 5 years, 10 years, probably we will put a condition. So government has some incentives. If you look at my slides, if you are recorded, one slide is there where if you are doing a battery manufacturing in the country with 50% tie-up with a foreign, let's say foreign know-how, government is ready to give them loan. But it should be in mega level. That is why people only like Tesla can start it. So every state, including Kerala state, every state is promoting electric vehicles. State has policies. Karnataka has a program where they provide some free land, free electricity for anyone who is going to manufacture electric vehicles. So electric vehicles are concerned, there are 3 segments. One is DC motor segment, other one is battery, and third one is charging platform. So all these 3, government has a plan. Unfortunately, they are all going little in a slow manner. But there is no doubt that as time goes on, the share of electric vehicles will increase. Maybe after 10 years, we'll only have electric vehicles. So policy level changes, I'm sure they are very slow to come. Bangalore has a big plan to make a charging platform. I don't know about Kerala, but Kerala has bought a lot of electric vehicles from various foreign manufacturers.
Sir, there is one question in chat box.
Okay, let me look at the chat box. Yeah, Sibi Anaga. What is the fate of the batteries after its lifespan? Cause headache to the environment? I would say no. See, lithium batteries, there is recycling technology. Unfortunately, again, we are not done in a large level. 2 laboratories working on recycling of lithium batteries are, one is NML, National Metallurgical Laboratory, Jamshedpur. They have a thermoelectric or a pyrometallurgical recycling technique. And there is another laboratory where they do some hydrometallurgy to generate. So lithium battery recycling, most precious thing is cobalt, nickel from the cathode. Lithium is very small. Lithium actually shuttles between the anode and cathode. So the amount of lithium used is extremely small in lithium batteries. So that is not a concern. More important concern is the electrolyte, which is flammable, which can catch fire, safety issues. And then the cathode. Cathode has most precious materials. Cathode has cobalt. Cobalt is extremely important because availability is limited and very expensive. Look at the lithium battery, each component by component. Cobalt is the one which is most expensive. So one research trend is to make cobalt-free cathodes. People are working on that. So the recycling is concerned, lead acid battery is 99% recyclable. People are doing it. Lithium batteries are concerned, recycling is known, but India, unfortunately, we are not having any big plan. Tata mentioned that they are starting a big recycling plant in somewhere near Mumbai, and Mahindra also started, but these are all in newspaper reports. Nothing really has happened. So your question is very important. If you can take recycling, lithium batteries from many sources, you can, technology is known how to recycle. Now, I think one more question coming out. So the fate of these batteries after its lifespan is over, we know what to do. There are recycling plants. Recycling research is also going on. In our institute, there is one Dr. Aravindan who does work on lithium battery recycling. Anode, cathode, separator, electrolyte, everything can be recycled. So it doesn't cause a headache to the environment if you are recycling. If you don't recycle, there is a problem. What a common man should do to recycle the battery, how can he do it? I mean, approach the I think Bangalore, there is a recycling facility. They don't do battery recycling. They take the entire laptop, mobile, and they do recycling. But common man can collect all the recycling, all the lithium batteries and supply to a recycling facility. Now the recycling facility has not come because of it is not affordable. If you do suppose you want to start a recycling plant, technology is known, but the interest, you don't get any profit at all. Sometimes you will have only loss. So if government or these automobile companies, they invest, they provide you some fund to start a recycling, then it is worth telling that, look, I want to support the society. Developing a recycling plant, even in a medium scale, is not a big issue. You have to open the cells. Containers should be separated, cathode, anode should be separated. Problem is there are different type of cathode. So based on the material, some people use lithium iron phosphate, some people use lithium manganate, lithium cobaltate. So you need to know which supplier, which type of battery you have. Then there are battery configuration different. That's why it is intense. For a common man who can only collect the cells and put it in some place and supply. It is difficult because design of battery itself is different. Coin type of cells are there, then pouch cells are there, prismatic. So a person who is familiar with the battery technology, they can start. Okay. Any other?
Is there any questions?
What about recycling LED bulbs and its parts? Can be done easily. Glass is recyclable. In the LED part, light emitting diode part, if it is organic material, I don't know about recycling part because these are new things. But in principle, anybody working on materials chemistry can develop these recycling workflow sheet based on the type of material available. Recycling is important these days. Chemistry, whenever we talk about chemistry, we don't want anything lying in the environment. Most of the materials can be recycled, and the chemistry, we need to invent chemistry in such a way that recycling is encouraged, because India is also going to embrace circular economy. Circular economy, one of the critical aspect is that all feedback loops are closed. Nothing is to the environment. It's a good question. Does that answer the question? I think one more in the chat box. What about LED body? Yeah, I have been talking about that. Is there any safety precaution while dealing with body? Yes, very important. Even a small mobile or laptop lithium battery, unknowingly you short it, you'll explode like a bomb. It will be nice to do an experiment in your institute itself. Collect a one lithium battery, sit from long distance and try to short and see a bomb explosion. Okay, so safety is extremely critical. We hope that next generation lithium batteries will be solid state batteries. Their safety will be much more robust. Imagine the safety issue comes because of the solvent. Normal lithium batteries, we use liquid electrolytes, dimethyl carbonate and propylene carbonate or ethylene carbonate. These are the electrolytes used. Dimethyl carbonate, and sometimes you use propylene carbonate or ethyl carbonate, the mixture of these two. So these are flammable. They can, explode. So one reason for explosion in the cell is anode and then cathode. There is a dendrite formation while recharging. Dendrite causes cell to explode. So temperature will increase. We can prevent it in many ways. Sometimes you have a separator, what is called a smart separator. Separator is a composite, just not simple polymer like polyethylene or polypropylene, but it's a composite where the temperature increases, composite melts, and the explosion is prevented. Cathode and anode are isolated by virtue of action of the composite electrolyte. So this is one way. Second way is that solid electrolyte. We don't use liquid at all. So next generation batteries will have solid electrolyte. Sometimes polymer electrolyte, sometimes ceramic electrolyte. These are all researches going on almost everywhere to see solid electrolytes to prevent explosion. So that is why your question is very important. Safety precautions are there for every batteries. Make sure that batteries are not shorted even if they are dead. There can be sometimes, explosion. So lithium batteries are very small, but always insulate the cathode and anode. They should not touch together. And in cars and vehicles, there are, in fact, Tesla Model S car, 7,000 batteries, 7,000 cells to form a huge battery. If one of them short, explosion.
Thank you, sir.
Sure.
Any more questions? I hope that there are no more questions.
So how many faculty members are there? Chemistry?
4, sir. 4.
Oh, okay. They are physical, organic, inorganic. They take all branches of chemistry, right?
Yeah, we have polymer chemistry here.
Oh, your polymer chemistry also. Good. So actually, polymer chemistry, there are nice experiments in the kitchen. With corn flour. Corn flour is a very smart material where with the shearing, you will see the network formation is very good. So somebody should make corn flour and do some experiments, measure the viscosity, measure the properties. And corn flour is also added for many delicacies. You take groundnut, put an egg. A fat is only for the binding. Then you put corn flour. So you can make a coarse shell type of materials. So they are very nice recipes where chemistry is very important because the fat present in the egg white provides you the binding.
Actually, we don't have the practicals in polymer chemistry, only physical, inorganic and organic.
Okay.
Anyway, wonderful presentation, sir. Thank you for your valuable time.
Sure, it's a pleasure. Yes.
Yes, sir. Thank you, sir, for such an illuminating lecture, for reminding us about the kitchen chemistry and food chemistry, and also bringing us to the unseen side of this pandemic being done across the world to overcome this pandemic. Hopefully, we could get over this. Now we shall come to, now we have come to an end of the session 2. Let me invite Mrs. Anshal Elizabeth Mammon, Faculty, Department of Chemistry, Mahatma College, to deliver vote of thanks.
Respected Principal Dr. Rena Thomas ma'am, our Chief Guest Dr. Vijay Mohan sir, and my dear friends, it is indeed a great privilege to have Dr. Vijay Mohan sir as our Chief Guest for our second day of our webinar series. He is an eminent scholar and academician. Today, sir has delivered an informative talk on doing chemistry in the time of pandemic. On behalf of the Department of Chemistry and IQSC of Mahatma College, Chungatra, I express our sincere gratitude to sir. I thank Dr. Reina Thomas, our principal, for her constant support and guidance. I thank Dr. Raji Thomas, IQSC coordinator, for his constant support for the department. And I thank faculty members of various institutions, research scholars, and students, and all the participants of this lecture for their active participation in this webinar. And I request your cooperation in the coming lectures also. Thank you.
Thank you, Anshamas.
Thank you.
So, a small announcement. The third 2020 would be on 1st December 2020 at 2:30 p.m. by Professor T.S. Anirudhan, former professor of University of Kerala, on the topic Advanced Functional Hybrid Materials. Thank you.
Thank you, Anupama.